firstly start by drawing my vertical axis, which is defined by the velocity in meters per second, and draw as well the x-axis, which defines time in seconds. Now you would notice here the change in y. Well, let me not call it change in y, but call it d, right? So it is the distance between ball A and ball B. You can see that it is going to be determined by change in y max, meaning this distance, plus change in y of B. So I'm saying this distance plus this distance. To get the best out of question 3 of the November 2014 question paper, I highly recommend that you visit and watch my playlist of vertical projectile motion lessons. Now, to do this question 3, we'll begin first by interpreting the problem. The question reads as follows. A ball A is thrown vertically upwards from a height h with a speed of 15 meters per second. At the same instant, a second identical ball B is dropped from the same height as ball A, as shown in the diagram below. Both balls undergo free fall and eventually hit the ground. Now, what we are told here is that we have this ball thrown at an initial velocity, and then it goes up and it goes down, eventually hitting the ground. And this one here is dropped, it then goes downwards. They are set in motion at the same time, at the same instant. When this is thrown up, this is dropped, then they get to be in motion at the same time, meaning they move at the same time, going up and down. Perhaps the first thing that I can do with this problem really is to choose direction, to say any vector that goes upward is negative. So I'm basically choosing up as negative. That is to say, here I'm going to have negative 15 meters per second. So my initial velocity of ball A is really going to be negative 15 meters per second because I chose up as negative. Now obviously we know that this ball, when it gets to this point, will have v of a final to be 0 meters per second. Now I'm calling it final because this is the initial velocity. Now this is the velocity at the maximum height. The ball will stop for an instant, changes direction and goes downwards. Now the initial velocity of ball B is 0 meters per second because they used the word dropped. Remember, we said that when you drop a projectile, that means its initial velocity is 0. Now these balls, when they are in motion, they are going to experience the acceleration due to gravity, the force of gravity, because there are no any other forces acting here, so it's going to be the only force. But this force will cause them to actually accelerate at an acceleration of 9.8. It's a constant acceleration of 9.8 meters per second. Now, note that my acceleration is positive because we chose down as positive since up is negative. I think this is a straightforward, simple question. We are done with interpreting this problem. I will further classify this problem as one that actually requires the knowledge of vertical projectile motion, because really there's enough hints here to say it is under free fall, and it's a ball that is projected into the air, it's thrown into the air, so it's a projectile. So, and it moves vertically upwards and comes down, and it moves vertically downwards, so it's a vertical projectile motion. You can classify this problem as one that requires the knowledge of energy principles, work energy and power. We are yet to get there, so that means you can use those equations as well. You can also classify this as a problem that can use the knowledge of momentum and impulse. It is possible to also solve this using that, Newton's second law and all those fun stuff. Now that I'm done classifying my problem, I then go to answer my questions. If we look at question 3.1, so we are doing question 3 and we are on 3.1. They say to us that define free fall for 2 marks. We know that free fall is the downward or upward motion in which the projectile moves under the influence of gravitational force only. And this is a straightforward question that will give you 2 marks. We talked about this extensively in our lessons. This is what we call a concept question. It's a question that requires you to answer using words. Basically, you have to memorize your notes and then give your answer in words. So you can navigate this answer by just checking if there's any spelling errors or if your sentence is well constructed. That is the last thing that you actually do when you solve problems. You check them if they don't have any errors or if everything is okay. We call that problem navigation. So these are the problem solving strategies that you follow when you solve problems, and we call them here academic constitution. They're like rules that you follow, and they say that I can, meaning I can solve this problem only and if only you follow them. Now we'll jump then to answering, meaning we go back to a question 3.2 that says to us that calculate the time it takes ball A to return to the starting point. Very important. So now A will go up and come back here. The starting point we mean here at the height H. So what is the time that it takes to go up and come back down? How long does it take to go up and down? There are many ways in which you can solve this specific problem. I'm going to say here that we are looking for time 1, changing T1, meaning the time that it takes for ball 1. Well, not ball 1, but ball A. We're going to call it ball A in this case, to go up and come down. Now, one of the simplest ways in which you can do this is to realize that this ball moves here with an initial velocity of -15 and gets to the maximum height. So we can actually, and it has the acceleration due to gravity. That means we can actually use these 3 because we need 3 quantities to pick up our equation of motion. We can use these 3 to actually calculate the time it takes to go up. And to do that, I can use the equation final velocity of ball A is equals to initial velocity of ball A plus the acceleration due to gravity times changing time that it takes to go up. Very important, this is the time it takes to go up because I'm using velocity here and here and the acceleration, so I'm only finding the time for this part of going up. Now we know that V final A is here at the maximum height is going to be a 0, and V A initial is really negative 15, because remember we said up is negative, so it goes up with negative 15 meters per second. But our acceleration due to gravity is actually 9.8 times the time it takes to go up. It's a positive 9.8 because down is positive really. And from here we can simply use a calculator. We are going to take the 15 to this side so that we have a positive 15 when it comes this side, and this side I'm left with this 9.8 times change in time it takes to go up. Now I'm going to divide by 9.8 so that they cancel, and I'm left only with this. So this means this side I'm dividing 15 by 9.8. Now here we have 15 divided by 9.8, and that actually says the time it takes to go up is actually equals to 1.5306 seconds. Now I didn't round off here because this is not the final answer. Remember, we only found the time it takes to go up, but we know that vertical projectile motion is symmetrical. We have what we call time symmetry in vertical projectile motion. That means that if I'm looking for the time t1, what I called not t1 but ta, what I called ta, which means the time that the ball A will take to go up and come down, it will actually be 2 times the time it takes to go up, because the time it takes to go up is the same time it takes to go down. So if I add those 2 times, or I multiply them by 2, it will give me the time it takes to go up and down. Notice that in this question I don't use the word total time, because total time would mean when the ball is here, because total time is the time that it is in motion, that is, it has completed its whole motion. So remember, when it's here, it's still in motion. It is just to go up and come down, then it will still go down. So we only want when it comes back here. Now this would simply mean that I'll take the 2 and multiply the 1.5306 and so on. Now this again would simply multiply this answer by a 2, then we get the time it takes for ball A to go up and down to be 3.06 seconds. You can use other equations of motion to calculate this time. They'll work perfectly well. Or even the impulse momentum theorem. You can basically use Newton's second law or the definition of impulse. It will really give you the same answer. Now this question is going to be marked out of 4 marks, where they're going to give you 1 mark for the correct formula, 1 mark for the fact that you realize that at the maximum height the velocity is 0, and 1 mark for substituting the correct numbers there with the direction. And the other mark will come from writing this final answer, and all these other calculations. They should take you 1 minute. Now, to navigate this problem really, which is the last rule of n, you can really look at your numbers. You can see that we have a relatively small velocity, 15, and the time it takes to go up makes sense to be 1.5, and double that should be that answer. And also the nice thing with looking at our time, I see this mistake here. It should be changing to here. Looking at our time, we can see that comes out as a positive number. That's where also that you're in the right path when you calculate time, because time can never come out as negative. So that's another thing that you can sort of have confidence in saying that your answer is correct. Now, after navigating that answer, we can go to question 3.3, which says calculate the distance between ball A and ball B when ball A is at its maximum height. very interesting question, especially because also it is worth 7 marks. It means we're going to do a number of calculations and a lot of thinking as well. Now we are saying here that when ball A gets to the maximum height, when it is here at the maximum height, when this ball A gets to the maximum height, remember that when ball A gets to the maximum height, ball B would have moved downwards. Maybe it's somewhere here, I don't know, it will depend. Now we are saying that what is the distance between these two balls? So this here is ball A, and we're saying ball B will be somewhere here. So what is the distance between these two balls? What is this distance here? Right, how can we quantify that distance? Obviously I can focus, to answer, the best way to answer this question is to focus on each ball separately. When we look at ball A, we can see that we can find this height here, and also when we look at ball B, we can find that height here. Then we can somehow combine or add those two heights. It becomes really a simple problem when you do it like that, when you look at them separately. Now to get the height for ball A, I can still use the initial velocity, the final velocity at the maximum height, and I still have the acceleration due to gravity, and then I can find the height. To do that, I'm going to actually use the equation that says that the final velocity of ball A squared is equals to, this is ball A, not B, the initial velocity plus twice the acceleration, and here we have change in y. I'm going to call this change in y max. So what I'm saying here is that I'm calculating this height here and I'm calling it change in y max because it is the maximum height of ball A really. And I've just labeled it ball A VA to say it's ball A. It is possible to use other equations as well where you use the time because we calculated the time. I always advise that do not use those equations in a question like this, because if you found the time to be a wrong answer in the previous question and you take that wrong answer here, you risk losing marks going downwards. But if you use the information that you didn't calculate, that was given in the problem, like the final velocity is 0, the initial velocity we know that is negative 15, we also know that g is 9.8. you then are in a position where even when here you've lost marks because maybe your final answer is wrong or you have done something wrong there, you are able to still get full marks on the next question, 3.3 in this case. Now going forward with this question, we know that at the maximum height the velocity is 0 and this object starts with a velocity of negative 15 and we have 2 times 9.8. Very important to remember that our direction, how we chose our direction there, and we are really calculating the maximum height of ball A. Now this question here, we can use our calculator to determine 15 squared. So this side we're going to have a 0 and then this side we have a 225 plus this is 19.6 change in y max. Now I'm going to take this 222 this side so that I have negative 225 and I'm dividing that by the 19.6 because when we divide by 19.6 here it will cancel and then I'm left only with change in y. So this means that our change in y max is going to be equals to this number here divided by 19.6. Okay, remember that, let me write this properly so that we don't get confused. We have negative 225 because it's going to be negative when it goes to the other side. Then we have 19.6. So this means I have here negative 11.4795 and it goes on like that. Now, I'm not rounding off here because this is not the final answer. It's only the height from here to the maximum height. Then from this stage, we are going to now determine the height of the second ball. I need us to reinterpret this problem. Remember that when ball A is thrown upwards, ball B is dropped, so they move really at the same time. So this is to say that as this is going up, this is also going down. When this reaches this point, this one would be somewhere here. So we'll have ball B being somewhere here. So our height will be measured to be a height somewhere here. Now you would see that they will take the same time to go up while this is going down. So as this is going up, the time is counting when this is going down. By the time this reaches the maximum height, this will be somewhere here. So that means the change in time here to go up, which was 1.53, I think we calculated that. Yes, the time that it took for this to go up, which was 1.53, would be the same time that it takes for ball B to actually go down. It will also take 1.53 seconds to go down, because they really move at the same time. Now what we are saying here is actually that the change in time to go up for ball A is actually the same change in time for ball B to go down, and they're given by 1.53. We didn't round off that, 5306 seconds. Now what we have now here is that we have the time it takes for ball B to go down. We also have the initial velocity, and we have the acceleration due to gravity. That means we have three quantities, and that would suggest that we can use the equation change in y. I'm going to call it change in y B, to say it is the displacement of B, or the distance of B is this distance here. The change in y of B is equal to the initial velocity of B plus the time that it takes for B to go down. Then we have plus 1 over 2 the acceleration due to gravity, and times that time it takes to go down. Now from here, this becomes a very simple substitution problem, where we know that this whole thing will be 0 here, because remember this thing is dropped. So if I put 0 here, this whole thing will multiply out to be 0. Then I have plus 1 over 2. Our acceleration due to gravity is positive here because we chose down as positive, and we know that the time is 1.5306 all squared. Now from here, this problem becomes very, 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 very boring, because we can literally punch everything here in the calculator. We're going to have 0.5 multiplied by 9.8 multiplied by 1.5306 all squared, and that gives us the displacement, or the distance of B, to be 11.4794. I'm not going to round off this as well, because it is not the final answer. Now what have we done now? We have actually determined the maximum height here. We also have determined this height here. Now to get the height between these two balls, this whole height here, what I will call, or perhaps let me draw this from this side so that it is visible. So we're looking for this height here, the change in y. Well, let me not call it change in y, but call it d. Right, so it is the distance between ball A and ball B. You can see that it is going to be determined by change in y max, meaning this distance, plus change in y of b. So I'm saying this distance plus this distance would actually give me that distance. Now I'm going to write that equation down to say we are looking for the distance between ball A and B. We can say AB, so that now it is going to be given by change in y max plus change in y of B. And this means I have the 11.4795 plus the 11.4794, and when we press this on our calculator, we get the distance between A and B to be 11.4, that is 4795 plus 11.4704, and that says our distance between these two balls would be 22.95 meters. Now we can quickly navigate this problem. I think the interesting thing that caught my eye is that the distances are almost the same when you look at them. The distance for B when it goes down and the distance for A when it goes up. This kind of makes sense to me because, if you look at the motion in a different way, if you look at A, when it comes down, it will start with a velocity of 0 and it will go down for the time of 1.5. And when you look at B, it also starts with a velocity of 0 and it takes 1.5 to come down. So these distances will almost be the same. They're almost the same because they take the same time. And of course, when they go down here, both of them, they move at the acceleration of 9.8. They have the same acceleration. So these motions are actually identical when it goes down. Even though on the calculation, we had the information of the ball when it goes up. So my answer, would make sense that these two are the same or almost the same. And when I add them, I get double the amount. That's how you can navigate this problem to see if it makes sense. The other thing, you may check that you have calculated the correct thing and the SI units are there. I didn't write direction here because distance is a scalar quantity. It's just the length between the two objects. Now, this question is marked 7 marks. It's very important for us to know what we are going to get marked on. We're going to get a mark for using that equation, for substituting the correct direction and value of the initial velocity, and substituting the correct 9.8, the acceleration due to gravity. The other mark will come really from this part of the equation. So it's either they mark 1 mark for this and 1 mark for substitution. And or they mark 0 here and 1 mark for that. Either way, it's worth 2 marks, that one. And the last 2 marks will actually really come from building this equation and substituting correctly and finding the final answer. That should be 1, 2, 3, 4, 5, 6, 7. Now we are ready to answer the last question, which is 3.4, and this question says to us that sketch the velocity versus time graph on the answer book for the motion of ball A from the time it is projected until it hits the ground. Very interesting question. Now they say to us that clearly show the flow in the graph. Now this is very important instructions because this is what they're going to mark. You really have to show what they ask you here. On our graph, we should see the initial velocity, the time it takes to reach the maximum height, and the time it takes to return to the starting point. This one is what we use to draw the graph really when you apply the method that I shared with you in the Scienceless channel. So 3.4 the first thing that I'll do is putting a title to say I'm doing a velocity versus time graph here. I'm sketching that graph. And we know that when we sketch these graphs, they are actually a straight line graph that is defined by final velocity is equals to initial velocity plus the acceleration times change in time. Now, the first thing that we have to notice here is that our acceleration, which is the gradient, is actually positive. That means we are going to have a graph that is uphill, because when the gradient is positive on a straight line, it's a graph that goes uphill. And our initial velocity is a point here at the bottom where our graph starts, and our graph starts with an initial velocity of negative 15 meters per second. So basically we are going to take this and put it on our Cartesian plane. Now, to draw that Cartesian plane, I'm going to firstly start by drawing my vertical axis, which is defined by the velocity in meters per second, and draw as well the x-axis, which defines time in seconds. Now, you would notice that we're saying the graph will start at negative 15 meters per second because, that is our initial velocity, which shows upwards as negative. And we're saying this graph goes uphill. It means from this point going up, we need to have a graph that is actually going uphill like that. Now, the other aspects can be constructed on the graph, because we know that this part of the motion represents when the graph is going up, right? Because it reduces its velocity until it gets to a velocity of 0 here, when the time at the maximum height is actually defined as 1.53 seconds. Remember, we calculated the time at the maximum height to actually be the time it takes to go up to be 1.53, and we said that the time it will then come back to point A is actually 3.6. So now here, this one we really have to be careful. It's a time somewhere here. This is 3.06, because remember, the time it takes to get to this point will be the same time it takes to get to the point. So we're just doubling this to get to that 3.06. Because these motions here are symmetrical. They're exactly the same. The motion this side is exactly the same as the one at the bottom. Because vertical projectile motion is symmetrical. It has time symmetry. It has velocity symmetry. In fact, the velocity that we're going to have here will be a positive 15 meters per second. It will be the velocity that the projectile goes down with, the ball goes down with, is the velocity when it actually went up and comes down here. It will come down with the same velocity of 15, because this is negative, this is going to be positive. It's going downwards after a time of 3 seconds roughly. The other thing that they said we should put here is the time it takes to return to the starting point. Yes, so I've done maximum, I've done initial, I've done that. Yeah. Now you'll notice that past this point here, the projectile continues to go downwards. Is this part here? It continues to go downwards in the positive direction. But we don't have any information. We don't know at what time will it stop and what velocity, because we never calculated those in the question. And that's why even on our instructions here, we were never asked to put anything around that. So my graph looks correct. I've answered everything. Basically just putting what I calculated on the graph. Now we are going to get a mark for writing the initial velocity, writing the velocity at the maximum height, writing the velocity when the ball returns to the starting point, and the correct shape. The fact that our graph is going up, because we chose upwards as negative. So our graph should actually have a positive slope, because our gradient is positive, it's going in the positive direction. Remember that if you choose upwards as positive, if you choose direction in the other way around, your graph would be something that goes in that direction. So that's why they mark that shape.